everybody. Well, it's that time again. I have a new lifter model I want to show you. This particular lifter model is based on an earlier one that I had made. It was called a lifter with a sliding pinion, and the reason it was called a lifter with a sliding pinion is because at the base of the carriage I had two pinions that slid back and forth along the base of the carriage, so that when the carriage was tilted they would occupy their position on the rack. With this particular lifter, I've moved those pinions up on a fulcrum support arm. So they are at the end of these arms that are attached to the base of the carriage. And you can see as the carriage is tilted, these fulcrum support arms push the pinions up their vertical support, and they acquire new positions on these rack pairs that are on either side of the vertical support. This particular lifter has the 2-to-1 ratio on the drop cable. Once again, that keeps the amount of torque that I apply to my gear train to a minimum, or at least it cuts it in half. So if I put 200 pounds in the carriage, I have 100 pounds of torque on this first drum into the gear train. I have roll-on, roll-off cables to keep the drop cable at least semi-tight as it goes up, so that you won't have to roll it up on the drums whenever it gets to the top. And this is the pinion release or carriage release mechanism. It just disengages the pinions from the vertical support, so that when it comes time to drop the carriage, I can drop it down. I've got planetary gear and the little generator and the satellite lights. They all came from the gravity light that I purchased some time ago. And of course we have the tilt support arms that have become pretty standard, at least for this type of carriage, which is more square than it is tall than wide. So other than that, this is pretty much a standard lifter. It's on a new platform. It's on a 4x4 platform, which has these angle supports on each corner to keep the vertical support up straight. Get you a closer look at it, and then we'll load it up and drop it down. You can see that these two baskets that sit on either side of the carriage support are big enough to hold about 5 of the 33-pound cinder blocks. So that gives me an opportunity to put about 300 plus pounds in this particular lifter. You can see I have a cable going between on the other side there that goes to the fulcrum release mechanism. And I have two large rubber wheels here at the bottom. They fit perfectly between the two racks on each side, and they give stability and to the carriage as it's tilted up. It keeps it from swaying or rocking back and forth, and it holds it in a position whenever it's coming down. With this particular lifter, I can take it up about 3.5 feet. So let me load this up. There we go. For this demonstration, I didn't put 5 cinder blocks in here. They fit vertically across. And I don't really have the gear train set up to handle that much torque. So this is 33, 33, and about 20. So I've got about 86 pounds here and 86 pounds on the other side. So that plus the weight of the carriage is up around 200 plus pounds, not much over 200. Okay, I've got it loaded up. It looks like we're ready to tilt it up as high as we can get it. And I've got a helper today. I've got my mom. She's going to do her part. So we're going to partner up on this and tilt this carriage up as high as we can get it. We got one more to go, I think.
Oh, okay.
That's it.
Oh, is that it?
I think that's as high as it'll go.
Oh, all righty. I thought I was going to get played.
We're going to have to get a footstool. So that's pretty good. That's not too much effort to go. We went about 2 feet. So.
And I'm 88 years old, so you can.
Mom's 88 years old and weighs less, certainly
100 pounds.
certainly less than what I've got in the carriage. Okay.
Anyway, that was fun.
All right. So it's ready to be dropped down now, and so we'll release the carriage and see what happens. There we go. That didn't take very long for us to get it up about 3 feet 9 inches. So Looks like it's about ready to come down. First thing you always want to make sure when you drop one of these is that your drop cable is fairly tight. You don't want it loose, because if you disengage one side of the carriage and the drop cable isn't supporting the carriage, then the only thing that's going to be supporting it will be the fulcrum on this side, and with all that weight on this particular side, it's very, very hard to pull and disengage the carriage from the vertical support. And you really don't want to do that, because if this is loose, then if you should get this one disengaged, your carriage will drop however far it can before it tightens up this drop cable. And that puts quite a bit of a strain on your drivetrain, so you don't want to do that. Whenever I disengage these, I like to put a little bit of weight on these action arms. That helps to pull the pinions, which are spring loaded, away from the vertical support, and makes it a little easier for that for them to stay separated. There we go. That was pretty easy. So it's coming down now. You can see the satellite light is lit up. And the little generator is being turned. With this particular setup, with this much weight, which is about, like I said, about a little over 200 pounds, and this generator and the two satellite lights, I'm getting about 15 minutes per foot drop time. I like to be able to add a little bit of weight if the lights aren't quite as bright as you would like. Then you can add a little extra weight. Right now I'm getting about 2.6 volts out of the generator. So I can add about 15 pounds easily. That's not a lot, but it does make a little bit of difference, and I could always add more if I wanted to. That brings the voltage up to a little bit closer, around 2.7, and it does brighten the lights a little bit. If I wanted to have a longer drop time, then I would have to make some changes. I'd have to add more weight to the carriage, and I'd also have to change the gear ratios in the gearbox here. I have put in about 300 pounds in the carriage before, and I've put a small pulley, which is almost half the size of the current pulley that's on the little generator. So a smaller pulley on the generator means that I have to apply more torque to the generator to get it up to this particular RPM. So putting more weight here and changing the pulley on the output to the generator gives me about 20 minutes per foot. So 3.5 feet would easily give me an hour of drop time before I'd have to reset it. So other than that, there's not a lot to see. A slow moving carriage and spinning generator. Let me show you what it looks like down closer, just so you get an idea of what it looks like. Okay, well here we go. Looks like we've got some output here. The planetary gear box is turning the generator, and we're getting about 2.7, 2.6 or 2.7 volts, staying pretty steady. And these satellite lights are lit up. And the carriage is coming down ever so slowly. You can see the setting in front of the planetary gearbox is a ratchet clutch mechanism. It keeps the, it allows the torque to be applied to the planetary gearbox only whenever the carriage is being lowered. Otherwise it slips as the carriage is tilted up. Setting off of the two winches or two large sprocket gears. They have metal plates on either side to reinforce them, since they're closer to where the heavier torque is being applied. So you can see that the planetary gear has a adapter on it, and that adapter allows me to use a number 25 chain on it instead of the ball chain that came with it. These large blue and small blue gears, sprocket gears, they were printed out on a 3D printer, and they really worked quite well. I have another light here I'll show you. It's a light that I had purchased at a convenience store. It uses batteries, and it's got a strip of LEDs in it. Let me hook that up and I'll show you what it looks like. You might notice whenever I remove the load from the generator that it will immediately start to spin up. And the voltage shoots up to about 16 volts. Without a load on the generator, it comes down pretty fast. Restore the load and everything goes back to normal. Guess that's something that can be looked into, just like wind generators. You don't want the load to be removed from an active wind generator, because without a load your generator will go into a runaway condition, and it can damage not only it can damage the wind generator. So this little light puts out quite a bit of illumination, and it uses about the same amount of voltage. It's at about 2.8, so it uses a little bit more, not much. And it's almost as bright. I'd say it is as bright, just the way the light's distributed. So other than that, there's not a whole lot to see that you haven't already seen. This is a fairly well-performing lifter. It's repeatable. I've tilted it up and dropped it down many times. So I hope you enjoyed that. If you're building lifters, I recommend that you be careful, follow some safety procedures, don't be careless, and build more lifters.